We're going to continue the infrastructure discussion by talking about CDP, which is Cisco Discovery Protocol. And it is a layer 2 protocol for discovering devices. That's why they named it Discovery Protocol. So it runs on Cisco equipment, and it's able to run on different equipment. Some people can actually some different vendors can run the CDP protocol, but it's most commonly found on Cisco equipment. So it allows you to find different Cisco devices in the network, and if you don't know the network topology, it can definitely help you build that out. The way that it operates is it operates on all media that supports this sub-network access protocol, SNAP, which is going to be your LANs, and I think Frame Relay does that too. I have to look that one up too. But anything that uses the SNAP protocol is what it's going to operate on. CDP actually sends these advertisements out using a multicast MAC address, so a layer 2 multicast. So it's this, I'm not going to say the MAC address for you, but it's zeros, ones, and a bunch of C's. So if you see something like that, but yeah, it's CDP multicast MAC address. Do yourself a favor and try to memorize that MAC address and things like this. These are perfect things that they can take and test you on. Even though you can look up that MAC address anytime you want, that might be something that they could test you on. Just to throw that out there. So CDP messages are made up of, you have version, you have these time to live values, which is, how much, time it has to live, I guess, if there's another way to describe that, TTL value. So how long that message is going to be valid for, essentially. There's going to be a checksum to validate that message, that it's an accurate message and that everything was received correctly. And then you have these TLV fields, which are type, length, and value fields, which are going to be basically what you're going to view in the CDP protocol, what's interesting information for you. So Mike says, or the IETF standard LLDP. We are going to talk about LLDP in a few minutes here. LLDP is the standards-based version of CDP, essentially, if you don't have Cisco devices in your network. So the TLV fields that we just spoke about here for CDP, what are you going to be interested in trying to find out about your neighbor? You have device ID, which is sending the device's host name, the sending device's host name, that is. So if you do a show CDP neighbor, which is the command to see CDP relationships, you're going to see, this device's host name in there. Also, the address, which is the IP address of the sending interface. And you're going to have the port ID, which is the port that device is actually connected to. So it gives you a lot of information here that's really useful for you, obviously. You're going to find the capabilities of the device, what the device is actually going to do for you, or what it can do in the network. The version, which could be firmware version, iOS version, call manager version. It can give you a lot of different information there. Platform, which is what that version is running on, or what kind of software it's actually running on, whether it's full duplex, whether it's in a VTP domain, and also the management address of the device if it's actually an applicable thing. So I believe the next slide here has an example. So you can see the command I ran was show CDP NE, which is short for neighbor. And you can see the different devices that this host was connected to. You have a switch, you have this SEP thing, we'll talk about what that is, and you have the Q module that I actually had here, which is Cisco Unity Express. These SEP devices are actually phones. And for bonus points, does anybody know what SEP stands for? Go ahead and type that in the chat window if you know that. But these are going to be the MAC addresses of your phones, and they're obviously running CDP as well. Let's go ahead and put an example up here so you can see. Got R3 here. But all right, Celsius Ethernet phone, very good. Company Cisco bought. I like that one too. Good deal. Good effort, guys. All right, now let's go to HQ. I think it might be more interesting. So if I do show CDP neighbor at HQ, you can see the different devices that were registered to. So obviously it's working over Frame Relay. So you get this connection to R2. You also have a connection to R3. And you can look across this list here to see. I'm sorry, I'm kind of cutting it off a little bit. You can look across the list on the bottom here to kind of see what you have. You have port ID, platform, capabilities, hold time, what interface is actually connected to. But if you want to look at more information on these neighbors, you can pull up the neighbor detail. So if you do show CDP neighbor, and let's say serial 01102, and let's utilize the copy paste function of Secure CRT. And we can type detail at the end of that. And that's going to pull up a nice little picture of what we're looking at here. And this is a good thing to pop into a little notepad file or report or something, so you can kind of see what you're connected to. But it's easy to see here. You get it tells you the IP address of the phone that we're connected to, the router, the platform that it's running. So you see it's at 2911. And what the hold time is that you're seeing there, capabilities, what it can do, router switch, IGMP, and then what the version is, whether it's in a VTP management domain, which it is not. For those of you who have routing and switching CCIEs, VTP was not a fun thing, and it can be very deadly to your network. So don't run VTP if you can avoid it. All right, so let's see. No questions. Okay, good. So that's what CDP looks like there. So let's go into PowerPoint here and go to look at LLDP. LLDP is Link Layer Discovery Protocol, and this is the standards-based protocol that Mike had mentioned in the chat window there. It's primarily used for non-Cisco endpoints. So if you have a device that can't run CDP and you want to be able to discover that device based on some type of discovery mechanism, LLDP is your best bet. So LLDP-MED, Media Endpoint Discovery, detects power and voice VLAN on non-Cisco switches. So it's able to detect what type of power that's running and help with the actual powering of the phones itself. And the voice VLAN, it can pull that up and show you what the voice VLAN is essentially on LLDP. It supports third-party phones, of course, because that's kind of the point. I mean, if you can't... If it is not a Cisco phone, then it can support other phones, third-party phones. It sends information every 30 seconds, and it has a hold time of 120 seconds. So for those of you familiar with routing protocols, it's kind of similar to how a routing protocol might work. RIP, I think, does almost those exact timers. But anyway, so it'll send these packets every 30 seconds to say, hey, I'm here, cool. And if it misses, a couple packets, up to 4 packets here, if it's 120 seconds, it's going to say, well, I declare that neighbor dead, or it's not there anymore, I can't see it. So that's what the hold time is. And it is disabled by default on Cisco routers and switches. So question here from Fozzie, so I can run it between Juniper device and Cisco device? Yes, absolutely. That's a good example of what LLDP would be used for, because Juniper devices probably, aren't going to run Cisco Discovery Protocol. I could be wrong on some of those devices, but I think most of the time you're going to have to use LLDP for that type of situation. Thanks for the question on that. All right, here's an example of the TLV fields that are in LLDP, and you're going to see that they're similar. There's kind of different names than CDP. You have a port description, where the port's sent from. You have a system name, system description, capabilities. So you're getting the same type of information. You're also getting VLAN ID and MAC address. So those things are pretty important. And also, I forgot to mention, one thing that's really important with the MAC addresses is obviously if you don't know what phones are connected to your system, which might be the case in your Proctor Labs rack, if you do get rental time from Proctor Labs, you can find the MAC addresses out by using CDP neighbors. Obviously, you're going to have access to that in other methods, of course. There's going to be documentation on that, but the best way to do that is by CDP. And even for the Cisco lab exam, Cisco Collaboration Lab exam, you can go in. What I like to do, anyway, to make my life easier, is go back to the console here. Let's do one where we have, actually I don't have phones connected there. All my phones are local here in the office, so let me just go ahead and show you that from here. Actually, I think what do we have, some on Site C there? Yeah, all right, so here's one on Site C configured, and this is actually physically connected to the rack. So it shows you the MAC address, which is great, because then you can copy that and then paste it anywhere you want. So that configuration is going to be very useful if you're going to add to CUCM, add to CUCME, that way you don't have to physically type that MAC address, because when you're under pressure, you're prone to errors. So definitely it's a good idea to copy and paste whenever possible. All right. So let me, let's see. Let me pull up the detail on this so we can see what kind of phone this actually is here. Show CDP neighbor gig 020 detail. And this happens to be a 9971 phone that's connected to this rack here. There's the IP address there, and it's basically the same layout as if you were looking at a server or whatever, or a router or whatever. But you're going to get different information in each of those fields. The version, for example, here would be the firmware version rather than the iOS version. Sorry to go back to CDP there, but I wanted to point that out. I didn't want to miss that. So the TLV fields basically are the exact same in LLDP and CDP. There's only a few little differences in there. But here's a sample output from LLDP. As you can see, it looks pretty similar. You have show LLDP neighbors, and then you have that configured. Here's a couple different switch ports. Essentially, is what it's configured to. And then you can do the same thing. Show LLDP neighbor detail, get the same type of details, TLV values, and that kind of thing. So that's pretty much all there is to it, to those discovery protocols there. So let's move on to voice and data VLANs. Now now we're getting into the fun part. Okay, this is starting to get a little bit less tedious and more like, okay, these are big concepts now. Voice and data VLAN are going to be what's connected to your phones. I mean, that's what's going to be the network that your phone connects to, the voice network anyway. Your data VLAN is going to be connected off of your phone. I mean, so if you look at the back of your phone, you can see you have two ports. One's going to be a switch port, one's going to be a PC port. Or on the newer phones, they call it actually a network port and a data port. So it kind of makes it a little bit easier to understand. So you can have a voice and data VLAN basically running through your phone at the same time. Obviously, if you have Cisco phones or you've worked in that environment before, you know that you can have a phone that's connected to a PC. And that way that your PC has internet access through your phone or network access through your phone, and then you don't have to run a separate cable and that kind of thing. So that was a big advantage, obviously, of doing that. So, sorry, here, question. What is the command? Fozzie, what command? Which command are you referring to there? Sorry. For the written, should we get familiar with commands and outputs? I think. Sorry, I've been missing a couple questions there. I apologize about that. For the written test, the question is, should we get familiar with commands and outputs? I think it's a good idea to do that for sure, because you never know what kind of question they're going to ask you. I mean, they could say, for example, look at this output, and what do you see on this output? Essentially, they're going to ask you to look at it, analyze it, and give you feedback in a multiple choice kind of fashion, for that output. So, for example, it might take, let me go back one slide here. It might take this LLDP neighbors output and say, okay, what is the interface of the switch? I guess it's not a good example because there's 3 switches there. So it could say what interfaces are actually connected to the switch there. And then you could say local interfaces here are gig 00, gig 020, gig 021, and then you have these other interfaces that are actually the switch interfaces that are connected. So that could be a good question. Which interfaces are the ones that are connected to the switch? Which interfaces are the ones that are connected to the router? I mean, that might be a good test question right there. So definitely a good thing to note is configurations, screenshots, or command line stuff is definitely not off limits for the test. All right. All right, so voice and data VLANs. Let's see. So, what a VLAN actually does, I should probably start there, I guess. You know, it's obviously going to be essential for your network to run the phones and stuff. And you have the phone port or the network port and the data port on your phone to run those different networks. But the first thing about VLANs is that it breaks up the network. It breaks up the actual switching domain into multiple different broadcast domains. So, what does that actually mean? I mean, you have a switch, for example. Actually, you know what? Let me draw this. That might make it even better. So you have a switch. It's a red switch. And let's just mark the ports with X so you know that they're ports. And if you can't tell, man, I am just a stellar artist. So hope you're enjoying that. So no, this switch, the whole entire switch is a broadcast domain by default because everything is on the same VLAN. So if you're connecting, phones or endpoints or whatever, and it sends a broadcast request out, that means every port's going to get it. So that's what a broadcast domain is. So if you have multiple different VLANs, let's say that you have a VLAN of ports right here. Let's call that VLAN 19. And then another VLAN of ports here. Call it VLAN 100. And then these ports don't have anything assigned to them. So this is just default. Or the default is going to be VLAN 1. So now we have 3 separate broadcast domains. So that means if somebody sends a broadcast out on VLAN 19, only these 3 ports are going to get it. So that's kind of the point. You don't want to have all these broadcasts going on your switch ports if you don't need to. So one thing that is good about this is that these broadcast domains are limited, but the way that you have to communicate at this point now is that you have to communicate with a layer 3 device because you've got your VLANs defined, your layer 2 is defined. It's almost like having 3 separate switches if you look at it that way. And from here, now you're going to have a routing device in between these switches in order to make that communication happen. So if let me pull this down a little bit. These actual switch ports, let's say that, pull up a different color here. That is a trunk port, for example, to your router. And your router now has got to run routing for all these different VLANs. You can also have trunks to different routers, but we'll use this one for the example. You can have this VLAN connected to this trunk port, VLAN 1 connected to the trunk port, and VLAN 100. By default, they all are. They're all allowed on that trunk. So you could have R1 be the default gateway for each of these VLANs if you really wanted to, if you routed it that way. But the point is that all these VLANs are on separate broadcast domains, and now to get from VLAN 19 to VLAN 100, you have to go through the router to do it. There's no other way. It's got to be routed at that point, which is better because then you avoid using spanning tree protocol and stuff like that. But don't want to get too much into the RNS stuff. So that's what the VLAN actually does and is right there. So it creates what it can look like, multiple sub-switches, which I just kind of showed you there. The IP phones, like I had talked about a little bit earlier, have the built-in switch, which is the voice port and the data port. So one is assigned to the voice VLAN, and then the other one is assigned to the data port, which is untagged. So on the switch configuration itself, you can go look in there and see that the phone is actually assigned 2 VLANs. One's going to be a voice VLAN, one's going to be a data VLAN. The voice one is the first one is going to use obviously for communication, but then that second one that's assigned, completely different network, just like we showed in the diagram there, and that's just a separate port on the phone. So that phone runs a switch that is able to essentially trunk to that switch, to the main switch it's connected to. So let me show you that real quick. Fatal network error. That's not good. Let's see. Apologize for not having this one set up right away, but this is, I believe, all right. So this is, I don't know if you guys can see that okay, it's pretty small. But this is the office switch that I have set up for all my phones. So you can see there, I do show CDP neighbors, you can see all the different phones there. But if I look at the switch port, let's say, you know, FA105. So show run in FA105. You can see that we have switch port voice VLAN 192. That's where the phones are at. But we don't have a data VLAN. So if I wanted to define a data VLAN, jump into configuration mode, and I would just do switch port access VLAN, and then whatever that VLAN happens to be. So 40, let's say, and that doesn't exist on the switch, so it has to create it. And so now anything that's plugged into that PC port or data port on the phone is going to be automatically in VLAN 40. That's all that really means. So, any questions on that? Overwrites it with data VLAN configured on phone. Yes. Yes. This will be, well, actually, the data VLAN configured on the phone it's automatically going to come out untagged. So this should be a new configuration for the phone. I think you can define it manually, but this should overwrite that. I can check that out for you, Dan. Question is if PC sends tagged to phone PC port. What does the phone do if it's tagged to the PC port? Well, I believe in that case it's going to overwrite it because that configuration is there, or the communication just won't happen. Because if it's trying to send a VLAN tag out for a VLAN that doesn't exist or whatever, that's not going to be able to be routable or something like that. I'll have to look that up, though. That's a good question, Dan. Okay, let's back to the lecture here. So, we have, obviously the recommendation is to run separate data and voice VLANs. And so that enables you to have a clear segmentation of voice and data traffic easily with your VLAN. Obviously, if you have a different network address, this is your data network, this is your voice network, now it's completely separate, and allows you to apply different QoS policies and manage your different networks in a fashion that you can say, all right, this is voice, this is data, it's completely separate, it's easy to manage that way. You don't want your data applications to necessarily interact with your voice traffic. Obviously through layer 3 is fine, but if you're on a LAN with your data devices and you're downloading a huge FTP file or something, that could affect your voice communication because that serialization on the link is going to be delayed when you have this FTP packet coming before for a little small phone packet. So you could get some delay and jitter due to that. All right. All right. Now we get into the IP routing and collaboration solutions. So obviously I have a CCI routing and switching, so this is kind of near and dear to my heart as well. So the inter-VLAN routing I kind of already went through. That was in this gorgeous diagram right here. So that way, I mean, you can have these, the red switch basically is all these different VLANs, and you have all the different networks in these VLANs, so three different networks that can be routed through R1. So it's not the prettiest diagram in the world, but I think that you can kind of get the point that R1 is the routing device between these three VLANs. You can also have, a different routing device, of course, for each of these different VLANs. So that's inter-VLAN routing. You can also, if you wanted to, let me go back to this real quick and pick a different color. You can take these ports right here, let's say these 3 ports, and maybe have a VLAN interface on the switch and turn that into a layer 3 switch. So if you have interface VLAN 19, now you can actually run your default gateway from your switch and then have a layer 3 connection to your routed network on your switch. So that way it doesn't even have to go to a different device. It's a good way of doing it, especially if you prefer to keep all the traffic locally if you can on that one switch, the access layer. So that's just another option that's good to know. So that's SVI is what that's called. Thanks, Fozzie. That's Switch Virtual Interface. So that would be what this blue thing is, SVI. All right. The next thing here, Service Advertisement Framework. This is a new technology that's on the CCI collaboration now, and it's been around for a little while, and it's not exactly super popular, but it's a pretty cool way to share routing information between clusters. Right now it's only used for call control discovery, which is the service that runs inside a Service Advertisement Framework. But this is going to be communicating with a routing protocol, EIGRP in this case, is going to be helping to run that solution. And it runs completely independently of the routing protocol that you currently have. You can have static routing, dynamic routing with OSPF or BGP or whatever else you got, and this will run right on top of it without any problems. So Service Advertisement Framework is just a way to allow different clusters and systems to share routes between each other using this call control discovery service. And we'll talk about that in a lot more detail later. That's just a little teaser for you right now. So IP routing and collaboration solutions definitely involve Service Advertisement Framework. The IP phone to UC servers, applications, and gateways. So it's important. I think the main point that you need to get out of this is that there's routing that exists in the network. You're not just going to be dealing with phones. If you have some type of routing problem, in the CCI lab, that may be, an accident or whatever, but it may be by design, So you have to know a little bit about, you don't have to know about how routing protocols operate or whatever, but you do have to know that, a route, if you don't have a route to a network on one device, you won't be able to get somewhere. So how might you remedy that situation? So if an IP phone can't connect to a UC server in some way, how would you make that happen? There's going to be a lot of troubleshooting involved in making that work. I might add that when you're configuring your phones to register, that's probably one of the most nerve-wracking times of the exam itself. Obviously you're not doing that for the written exam, but there's a lot of different things that can go wrong. Like if these lower level protocols and these base protocols that you're building on don't work correctly, or they're always going to work correctly, but if they don't work how you think they're going to work. So it's definitely good to know how all this stuff works under, below the phone level, so that way you can troubleshoot more effectively. Okay, Fozzie says thinks very good in a huge enterprise to use SAF. Yeah, a lot of enterprises use SAF for that purpose. If you have a lot of different DNs or different DIDs that you need to route throughout your network, definitely SAF is a great addition to the network at that point. There's also other options to do. You can use well, it's not an automatic method, but you can use SME to use a centralized dial plan as well, if you have a large network. But SAF does it automatically with some configuration behind that. The core distribution and access modeling. Obviously, it seems like pretty much every class you're going to take is going to have some variation of core distribution and access layer talked about. And if you haven't heard it before, what it is you have the core layer of the network as your backbone, which is you're going to have these high-speed links that are existing basically only to transmit this layer 3 traffic that's already been, policies have already been applied, that kind of thing. You're basically just aggregating a bunch of different links into one or two or whatever, however many your core is, depending on the size of your network. A couple routers or switches or huge networking devices essentially. The distribution layer is going to be your middleman between your core and access. It basically will take connections from the access layer switches and then apply QoS policies and if in some cases provide routing like layer 3 to those access switches. But what that does is aggregate all the access switches so it can present that information to the core, in a more organized fashion. And then the access layer is kind of a free-for-all, sort of. I mean, you have your phones connected there to the switch, all the endpoint devices. That's where the rubber meets the road, essentially. So you have these access switches now that are providing the VLANs for the phones and the power for the phones, and those access switches are then going to be connected to the distribution layer. So what better way to illustrate that than to illustrate it? Let me draw that real quick. So let me pull up the default color there. All right. So you're going to have, let's start with the access layer. Just make sure I'm not overlapping myself. All right, perfect. All right, so this is the access layer that's going to be connected to a bunch of different phones and endpoints. That's where your layer 2 essentially happens. All your layer 2 should happen there. And in previous iterations of the core distribution access model, your layer 2 might go up to the distribution layer, but never in the core, really. So, but now it's recommended that your access layer basically terminate the layer 2 connection and start a layer 3 connection. And I'll kind of show you what I'm talking about there, but the distribution layer, let's just make that 2 switches there. These can be switches or routers, of course, any device that'll run the protocols we need. Have a connection there, the switch is connected there, the switch is connected there, and then of course, I want to have redundancy. So now you have redundancy between your distribution and access layer. And of course, between the 2 distribution switches, you want to make sure that you have links there as well. And a lot of times you're going to have multiple links, or they'll be port channeled or something to provide more bandwidth. And then you're going to have, at the top level, you're going to have your core, which are going to be the BARs, if you know what I mean, big ass routers. So you're going to have this connection here, and then also a redundant connection. And once again, you're going to have some type of connection between all these devices, probably port channel or something like that. So from here, this is kind of how everything will be routed through the network. Different policies can be applied. Obviously, you can see now, have a visual of how the distribution layer is set up. I mean, you have distribution between core and access, kind of providing that interface between the two, and all the policies. If you have layer 3 terminate right here at this point in the network, then everything above that point is obviously routed. So that way you don't have to worry about spanning tree convergence, the different rules associated with that, the blocking on different ports and links. You can have all layer 3 and all redundant all the time. So that's the preferred method at this point. So hope that makes sense for you guys there. Any questions so far? Are we all good? Can you run VSS or a Nexus run VPC? I apologize actually for the lack of information in that area. I just haven't really worked with the Nexus a whole lot. Obviously I'm in the collaboration side of things, so I haven't really worked too much with those switches. Sorry about that, Fozzie. Can you make it access and also can you make it access and also? Yeah, you can just make it. I think your question is, can you just use access and distribution layer only and no core, or just access and core? You can do that. I mean, you don't have to do access, distribution, core in every single network. I mean, it's largely dependent on the size of your network and how much redundancy you want to have in there. Obviously a small network, you may only have one switch. So, I mean, but you don't have to have this type of design everywhere. But this is like the best practice type of thing that you're going to see pretty much every certification class you're going to take. They're going to quiz you on this core distribution and access layer. So, all right. So a couple of little things here on this slide here. VLANs should not span multiple switches, and that's because if you have a VLAN spanning, if you have a VLAN configured on one switch and a VLAN configured on another switch, then now broadcasts can happen between those two switches. And if you're have these inter switch connections, those could easily get flooded with broadcasts, and it's just not a good design to have VLAN overlap with another switch. So if you can, try to either stack them up, stack the switches or whatever, and have VLANs running on each of those switches. Just try not to go to have one VLAN, or I'm sorry, multiple VLANs across different switches there. The access layer extending to layer 3 is a popular deployment method and limits spanning tree. So I mentioned that already. It's a good idea to have layer 3 access or layer 3 all the way down to the access layer. And then redundancy, as you saw in the diagram there, is extremely important because obviously if a link goes down, then you have somewhere to fail over. A lot of these major enterprise LANs are designed just exactly like that, and then some variations, of course, as they see fit. All right, question here. Yes, you can solve this by a loud voice VLAN command. Okay. All right, moving on to bigger and brighter things. The IPv6 section here. So, Internet Protocol version 6. Everybody talks about how this is on the brink of being implemented. In a lot of cases, it's being implemented it's been implemented already. It's just not super popular with customers yet. I think a lot of the devices they have in the network are old, and they're not willing to upgrade, or they don't want to mess up a good thing. If it's not broke, don't fix it type of thing. So you have a lot of people like that. There are people though that are on the cutting edge and want to use IPv6. They want to use the benefits that IPv6 has for you, and of course, IPv6 provides a much larger address range. You have 128 bits of space for your address compared to just 32 bits for the IP address. So I think it's like 4.3 billion or so IPv4 addresses that you can have, but it's like 10 to the 23rd power or something like that for IPv6. I don't remember what the exact number is, but moral of the story is you can have a lot of stinking IP addresses for IPv6 because they have 128 bits for the actual address. The question here, UCCX support IPv6 yet? I don't think it does, in the lab anyway. Well, it actually might, I think in version 9, I think it does, but I don't think it's, well, we're definitely not using it in our topology, IPv6, for the UCCX server. Actually, I don't think IPv6 is on the lab blueprint either, but that's beside the point. It's on the written blueprint. That's why you guys are here. So anyway, I'll have to look at that and see for sure. UCCX IPv6. I'll get back to you on that one. So what does the address actually look like? So you have these 8 16-bit fields of hexadecimal characters. So a hexadecimal character is from 0 to 9, and then from A to F. So you can use any of those different combinations of characters to create an address. So obviously if you have 128 bits worth, that's quite a bit. So this, the example here, FE80, colon 0, colon 0, colon 0, colon 0, and then colon FFFF, colon A0A, colon D0B. So that corresponds to the IP address of 10.10.13.11 if you actually convert those characters from binary to hexadecimal. But as you can see, I mean, if there wasn't a time to use DNS, I mean, this is the time, because that's going to be, people have trouble remembering an IPv4 address. IPv6 is going to be even more difficult. So, an important thing to note here between these is that IPv6 addresses can be shortened using 2 colons instead of just the 1 colon to replace zeros, essentially. So, I mean, they figure there's going to be probably a lot of zeros in these addresses for some time until they actually build up, and they'll probably never be utilized in our lifetime. So, but anyway, these 2 colons can be used in place of successive zeros at the beginning, middle, or end, as long as it's only done once. So you take this example right here, and you can shorten that to FE80 colon colon FFFF A0A colon D0B. So that eliminated all the zeros, pretty easily from that. And then so you only have the rest of the string right there. So if you have the colon, just insert however many zeros it takes. Remember, there are 8 16-bit fields. So you know that there's going to be 8 fields. So if you have colon, take however many fields you have and just add it until you get 8, essentially. That's how it's done. So these leading zeros are optional. And so obviously the example becomes this down here with this colon, FFFF. Any questions so far on that? Okay, so moving on, the address types in IPv6. So you have a unicast, which is normally what you're going to have for IPv4 communication. It's communication with a single network destination, host to host. Pretty easy. Anycast is an assigned set of interfaces that belong to different nodes, but it's delivered to the closest interface, which is pretty cool. So, like, let's say that I'm sitting here in Chicago and I want to get to a web server that is running the IPExpert website. So that if I resolve the DNS, IPExpert.com, and I go to this Anycast address, it's going to pick the server that's closest to me. Maybe there's a server for IPExpert.com that exists in Chicago. Maybe there's one that exists in Michigan somewhere, or wherever the closest location is. But the point is, you can go to the area where that address is the closest. And since it's hierarchical, since it's all kind of laid out that way, it's set up where you can get to that closest interface. Multicast, of course, you guys are familiar with. One host will send a stream to many hosts. So if I'm on a network and I want to provide like a class presentation, just like this, for example, I might want to send that out on a multicast stream and to a bunch of different hosts, and maybe those hosts want to subscribe to the classes, maybe they don't. And there's different protocols to regulate that, obviously. But that's also available in IPv6. So am I missing a couple questions here? Third line of slide. Let me go back here. Okay, yeah, thanks, Dan. Appreciate that. Good point. Dan has pointed out, if you guys look at the chat window, Dan's pointed out the 0A0:0D0B. The leading zeros have already been eliminated here, but that's a really good point. So I'll have to make a note to change that in the slides there, because I want to be able to show that. So leading zeros obviously have been eliminated already from this, is what Dan is saying. So good catch on that. I appreciate that. Also, it appears to be 9 fields. One too many zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, one too many zeros. Good catch on that one too. Thanks, Russell. Good deal. See, slide improvement. That's why I'm going to wait till the end, because there could be some little improvements like this. Appreciate that. Okay. Moving on. So the addressing model here, you have 3 different types of addresses. You have link local addresses, which are basically for communication only on the link, as it would be described, link local. Let's say you have a router and a switch that want to communicate together, and they have a specific address for doing that, and that's called a link local address. A unique local address is the same as basically private addressing in IPv4. So like 192.168.whatever is private addressing in IPv4. You have the same type of thing in IPv6, which starts with FEC0, and then it says /10, which means that there's 10 bits for the network mask. The global address is routable across the internet, and that starts with 2000 and it's :3. So obviously the rest of that is going to be reserved for host space or different subnetting spaces. So you have your link local, unique local, and global address. CUCM itself is going to support one link local address on an interface and either a unique local or global address. So if you think about it, that's kind of the same way it does it right now. I mean, except with the addition of this link local address. So you have a link local address now on IPv6, but you can say your communications manager server, you say, I want to provide a private IP address, or I want to provide a public IP address. You have that option now. It's the same right here. Cisco IP phones support one link local address, multiple unique local addresses, and multiple global addresses. So you can have a phone designated with a bunch of different IPv6 addresses if necessary. The global address is going to take precedence, though, if you have a global address configured. Obviously, they're going to figure that out from the prefix that you use for the global address. That FEC0 is going to be your unique local address, and so that's how they tell the difference, of course. Let's see. With multiple addresses configured, the first one is used for signaling and media. So if you have 6 IPv6 addresses configured on your phone, it's just going to use the first one available for both media and signaling. So it just kind of simplifies things, so it doesn't have to figure out, I should use this one for a different reason or not. It's just going to use the first one. So how to enable IPv6 in CUCM? You can go to the system, server, and server configuration. So let's go there real quick, and I got timed out. So what did that say? System, server, and server configuration. So right there you can configure the IPv6 name, the IPv6 address as well. And then this is the second time we've been on this page today, so good deal. That's where you configure that on the server. It also go to enterprise parameters and set this enable IPv6 parameter to true, and that will allow IPv6 to actually function on the system itself. And also common device configuration for IP phones and trunks has IPv6 information as well. So let's see, common device configuration for IP phones and trunks. Let's look at that. So that's device settings, common phone, or common device configuration. Let's just add a new one so we can see. So you can see right here this IP addressing mode. Right now it's set to IPv4 and IPv6, but you can set it to IPv4 only or IPv6 only. So by default, it's both though. IPv4 and IPv6 is allowed anyway. Any questions on that? Okay. All right, now moving on to IP multicast. So I don't know if you guys have worked with multicast before, but it's basically a technology that allows you to stream different packets of information to different devices in the network. You basically only have to use one stream, and then these devices can subscribe to that stream. So it's just a way that you can run music on hold, for example, for Call Manager Cluster. You can have multicast music on hold for branch sites, for your local sites, and that eliminates the need to have multiple unicast streams. So that's the reason for multicast in the first place. A couple examples, like I said, multicast MOH for branch sites. Also have the auto discovery of gatekeeper messages, gatekeeper request messages, that is GRQ. We'll talk about that a little bit later. I have a question here. Written scheduled yet? Oh, sorry. That's a class-to-class chat. So the next thing here, DHCP v6 discovery by IPv6 endpoints. That's done through multicast. So that's another application of that. A SAF forwarder, which is Service Advertisement Framework forwarder, and automatic discovery and communication with other SAF forwarders is another reason to use IP multicast, another thing that does use multicast. So you can enable multicast with the following protocols that you see. IGMP is one that's going to be enabled on the access switches to determine whether a host is going to be able to, or determine whether a host wants that multicast stream or not. So the IGMP protocol is gonna basically take that request from the client device, and then you're gonna have this protocol independent multicast sparse mode and dense mode, which is just PIM sparse, PIM dense, PIM SM, PIM DM, whatever you want to call it. But PIM sparse mode is the multicast protocol that basically is only done on subscription basis. So it will subscribe to the multicast stream if it wants it. Otherwise, it doesn't get it. With PIM dense mode, everybody gets it, and if you don't want it, you have to say that you don't want it, essentially. So if no one subscribes to it, it's going to prune the branches essentially, and that's what that's called. So a multicast source is going to send through a network to everywhere if it's PIM dense, and then that source can be pruned off as it goes through the network, meaning that source could be cut off from continuing further down the network there. Okay, and then Cisco Group Management Protocol is similar to IGMP. It just determines what groups a multicast or a host would be connected to receive multicast traffic and information. And then for inter-domain environments, meaning if you're going to connect from one domain to another, you're going to have multicast source discovery protocol, which is MSDP, and then PIM source specific multicast. Those are just different ways to communicate between different organizations using multicast. All right, so I think that was in on multicast. Anybody have any questions on that? I'm sorry, I didn't mean to move too quickly there. We can always go back if you have questions on it. So I'm actually cutting off part of it there. I'll move when we get down there. So this next one here, wireless and collaboration solutions. Cisco has determined that you need to know about wireless and collaboration solutions in addition to all this other stuff. So get ready to pack your brain with this too. So you have 7925 wireless phone that Cisco supports this, or that Cisco makes to support the wireless requirements of if somebody needs a wireless phone to connect to their call manager system, you can use this 7925 wireless phone to do that. We have, what would be the boundary for domains? Let's go back here. For domains, I'm guessing the boundary for domains that we're referring to is multicast domains. And what that is going to actually, what that's actually talking about is multicast stops running a particular protocol out that interface. Let's say that you have, R1 filtering down multicast through different layers of the network to different devices on the LAN, but then you want to connect over the WAN, to another system or whatever. But that interface is not running that protocol that you have, like this PIM dense mode, for example, on your LAN. So you would use another protocol to run between those two, which would be MSDP or PIM source specific multicast. So I hope that answered your question. Yeah, I would say it's it can be used more on the WAN there, and that's a way to more efficiently do it. Essentially, set that up. All right, back to wireless. Thanks for the question there, Julius. I appreciate that. Wireless and collaboration solutions. We already talked about the wireless phone briefly. Just a way to connect to your call manager cluster with a wireless handset. Also, these newer phones, the 9971s, 8971s, or 61s, or whatever, can support wireless as well. You can connect to a wireless network with them. Also, these Unified Wireless LAN Controllers, WLC, those are going to basically allow you to manage your wireless domain. We don't have to configure them at all or know how to configure them for the written exam at all, but we do need to know that they exist and they can provide wireless service for these different phones. So if you have this wireless LAN controller that's running on a switch, essentially, you can connect to that through a web interface and configure different, radio frequencies to different areas, overlapping access points, that type of thing. So there's the wireless LAN controller option, but there's also these autonomous access points, which means they can operate without a wireless LAN controller. So, like that's most situations. Most non-corporate situations are going to have just an access point set up for general use. but they're going to be autonomous essentially, which means not land controller based. So noise levels now. Talking about noise levels, this is actually, overlaps with one of my favorite topics, which is audio engineering. I do that kind of on the side, do a little bit of mixing and mastering and recording, play guitar and stuff. Check me out on Reverb Nation. Nice plug. But seriously though, this overlaps with it a little bit because we're talking about decibel levels, signal to noise ratio. Need to make sure that we have optimal signal to noise ratios in order to communicate effectively. So right now the requirements for those, it says noise level should not exceed negative 92 dBm. And then you should have at least a signal to noise ratio of 25 dB. So those are important numbers to know, because if you don't have that signal to noise ratio at least at that 25 decibel level, or 25 decibels above the noise floor, then you're not going to get a good quality signal, and you may not be able to support a wireless phone for unified communications. I mean, when you think about it, this is all real-time traffic. So if that noise floor interferes with your signal in any way, you might have packet drops, delay, jitter, all the normal phone stuff that could happen to you. I got an LOL from Julius on that. Appreciate that. The signal strength should be at least negative 67 dB. So obviously those numbers match up there. You have 25 dB of room in between. For those of you who have trouble visualizing that, let me just draw that out for us here. So, lost my pen. Let's say that we have the noise floor that's actually operating. Let me draw a little. Dang it! I always do that. Draw a little graph here, and let's just say that this is amplitude of the signal, and then we'll put that in decibels, of course. And then it's kind of backwards from how you might think, intuitively about it, but a decibel level like 0, positive 0, is the hottest your level can be. I mean, you could be over 0, and that would mean that you're peaking the level essentially in audio engineering terms. But you can go all the way down to negative, infinity is the term for it. So that means that there's no signal coming in at all. But what they're saying here, what Cisco's saying, is your noise level should not exceed negative 92 dBm. So where is that? Let's put negative 92 dBm is pretty low. So let's just say that our noise floor is there. So, and then obviously I drew it like that because it can vary. It's not just, all right, my noise floor is negative 92. It could maybe pop up or pop down, depending on what kind of environment that you're in. And so it's saying now that the signal that you're getting from your access point, the signal strength, should be at least negative 67. So that means that's about up here or so, negative 67, which is still pretty low in terms of audio engineering type stuff, but we're talking about collaboration. So that's where your signal is. And then in between these 2 points, we have 25 dBm of actual signal to noise ratio. So that means you have 25 dB of solid signal coming in, and what that's saying is that that's all it needs to operate effectively. So any questions on that? Does that make sense to you guys? Right, sounds like it does. Okay, the next thing here is actually talking about cells. We have 20 to 30% overlap of adjacent access points with non-overlapping channels. So that's the general requirement. And when you design a wireless network, basically you're going to have these different cells that are going to exist. You're going to have one cell here, maybe one cell here, and then maybe another cell there. So I'm not drawing the Olympic rings. These are actually wireless cells. So they're going to be operating, let's say that you're running, 802.11b. And you can talk to our instructor, Jeff Redsink, about the wireless wireless technology stuff, but because he's our wireless instructor. But let's just say that you're running, 802.11b, 2.4 gigs, each of these cells, of course. So you can have a unified SSID across all these cells, which is the service set identifier for the wireless system. And obviously, that's the network name that you connect to. So if you're standing over here in this orange cell, you're getting this 2.4 gigahertz signal, of course, but the signal operates on different channels within the system. So you could have, let's say this is on channel 11, and then you could have this one on 1, or channel 1, and then this one on 6. There's non-overlapping channels in 802.11b, which is a wireless standard, of course, now that we have other ones. But the point is here, it's asking you to have 20 to 30% overlap of adjacent access points with non-overlapping channels. So 20 to 30% overlap. This doesn't exactly look like 20 to 30% of overlap at all, but this is an example of where a channel can overlap. So if I'm walking from this cell over here, well, I just kind of screwed myself because now I don't have wireless access. I'm not in a coverage cell. So we need to either make a different coverage cell, right here in this area to accommodate for that situation, or that's just not an area where wireless is supported. But obviously, if I'm walking from, this cell to this green area here, well, now you have the opportunity for these access points to actually hand off that session to each other, and that allows them to communicate more effectively. And if you have a bigger overlap, it gives more time for that to happen. So what they're saying is if you're running unified communications, you have to be doubly sure, since everybody's relying on that phone to be accurate and always available, to have the proper amount of overlap and signal strength necessary in the network. All right, additional requirements here for wireless. You have to have a packet error rate, which is PER, should not exceed 1%. So you can't have a whole lot of errors on your network, of course, because errors generate drop packets generate jitter and delay and pissed off people who can't run their phones correctly. Jitter should be less than 100 milliseconds. They've determined that is the number that you want to hit, or that you want to be less than. If you're going to provide good service to end customers. QoS for voice VLAN must be enabled to match the wired infrastructure settings. This almost goes without saying, because if you're going to have your QoS value, let's say, DSCP EF is the common value for voice QoS, and we'll talk about all that later, what that means. But for right now, just know that for voice traffic, DSCP EF is going to be your common delimiter, whatever. So if you are using, AF41 for your voice on your wireless network, then those aren't going to match. So by the time it gets back to the wired network, the traffic won't be prioritized appropriately. So it's important to always match those settings up. If you have EF in your wired network, run EF in your wireless network. Just match those settings up and make your life a lot easier. Also, the next thing here is keep channel utilization below 50%. What that means is, obviously if we go back to this diagram here, you can see 1, 6, and 11 are these different channels. They are, if you have a lot of people inside these cells, then obviously you won't be able to provide that proper service to those UC clients, because if it's over 50% utilization, at that point I'm sure it has adverse effects on the call quality. It's all about call quality here. So if you keep that utilization below 50%, that's the sweet spot essentially for the wireless communication. Last thing here, Cisco compatible extensions, CCX, should be enabled on wireless infrastructure where possible to save battery life on wireless phones. So basically what that is, it's just a way to optimize performance on the phone. Like if it's not being used, it can go into a mode where the phone only communicates at certain points, because it's running these CCX extensions. So any questions on that? Does that make sense, guys? Okay. Just a few more slides here on this section. All right, so virtualization and collaboration solutions. I know a lot of you guys have probably worked in this field since it's such a hot field at this point, all the data center technology and virtualization. So I'm sure a lot of you are familiar with virtualization, but just in case you're not, what it is a way to run a virtual server on top of a physical server. So you have these basically bare metal servers that you can install what's called a hypervisor on, and that hypervisor runs, a software like ESXi, which is VMware ESXi, which is a virtualization software. What that does, it runs a base operating system, and then within that base operating system, you can create different virtual machines. Those virtual machines can then be run just like a regular physical machine, and those virtual machines can be configured, in any way that you want, basically just like the physical machines would be configured. So the advantages of that is that it's going to consolidate your infrastructure. You could have, for example, you have a big enough UCS server or VMware type server that you're going to have in your environment. You could take 7 servers, 8 servers, and put them onto one single box, and that obviously is going to save you a bunch of space in your data center. It's going to allow you to have one single point of management for those devices. Obviously, you need to have redundancy built in to make sure that if that system does go down, then you're protected in that case. But it does allow you to consolidate the infrastructure massively. That's one of the major advantages of that. So another thing here, it says rapid deployment and maximum scalability. So rapid deployment meaning, like, let's say that you have UCS B series chassis and you can use like a service profile to just rapidly say, hey, this is the server that I want configured. This is the specs that I want on it, CPU, memory, hard drive space. It's easy to basically create a server, because you already have the physical components. All you need is to tell it virtually what it is. And that's B series actually, and we'll get into that a little bit later. That's a little taster. It's simplified upgraded migration as well. VMware has really cool features built into it that allow you to basically migrate these virtual machines to different physical servers without skipping a beat. I think in some versions of Call Manager this might be supported. I think when I was working at Cisco it wasn't. I don't think at a couple different versions of the OS, but anyway, you can actually set up a continuous ping to a Call Manager server and migrate that server from one physical server to another and have that ping never drop a packet. Pretty amazing stuff, I think. It's allows a lot of different configurations and maximum flexibility in configuration. vMotion is what it's called, Fozzie. Thanks for that. vMotion describes a lot of different things, and this, of course, is not a VMware class, but definitely it's good to know some of these things. vMotion is allows you to move a running VM from one server to another, but it also allows you to move a server that's been shut down, or networks around in the actual VMware client. There's a lot of different things you can do with that. Now in Cisco Collaboration, there are virtual solutions that exist here, and some of them I never had direct experience with, but definitely very cool solutions out there. UCS, definitely had a lot of experience on UCS in my customer environments, but they have two types of UCS servers. You have the blade servers, which are the UCS B series, and the rack servers, which are the UCS C series. So the blade servers obviously are pretty awesome. I mean, I don't work at Cisco anymore, but I can help sell their product and say that they're awesome, because I really do think that they have a lot of great advantages that maybe other servers don't have. So these blade servers, allow the different configuration, like I already previously mentioned about service profiles, and able to just drop a profile on a machine and have it instantly create these different physical servers for you. The UCS C series servers are basically just like your MCS servers, except they're going to be allowed to run this virtualization platform like ESXi, and so that will allow you to run the VMware vSphere client to connect to it and configure virtual machines and so forth. So UCS is the basic core of the virtualization drive for Cisco. So the question here, without invalidating your license, is yes. You know what? That's that's a question for Cisco folks. Actually, I'm not sure what the support is on that, because I know that I've tested it out personally myself, and I never had any problems with licenses. But there may be some things that prevent it from happening now. If they change the licensing system up a little bit. So I'm not really sure on that, but I think in the testing that I did, it never invalidated any licenses to move it. You're not changing the IP address at all. So maybe that's what your question was, because normally when you change an IP address, you're invalidating the license. So you'd have to rehost that license again if you wanted to change the IP address. But this case, keep the same IP as long as that networking requirements or the networking is built behind those servers to support the different networking the different hosts coming from each port essentially. Then it'll work just fine. So let's see. vMotion is supported with many caveats. Yes, indeed. Thanks for that, guys. So vMotion is supported with many caveats. It has to be a manual move and only on the same SAN. As long as none of the factors in your virtual license Mac don't change. Right, exactly. So nothing should change in your Mac for that. Everything should be still associated with the same server or virtual machine or whatever. So that's UCS in a nutshell there. Cisco Virtualization Experience Infrastructure, VXI, is an integrated UC platform for enterprise voice, video, mobility, and presence. So it allows you to run these different things virtually in your own infrastructure, essentially with this VXI client. The VXME, which is Virtualization Experience Media Engine, enables Jabber to run in virtualized environments. So that can be an asset to you if you're wanting to run Jabber in that method, of course. The Cisco Virtualization Experience Client, VXC, is a thin client which is designed to easily integrate to virtualized infrastructure. So a thin client is, like for example, just a little device that's not a computer. It connects to a computer that would be on your desk, and it allows you to almost emulate you having a PC at your desk, and you're interacting with what you think is a PC, but it's actually located in a data center somewhere. So that's a thin client. It connects to that infrastructure on the back end. VXC Manager is used to, of course, manage and deploy those thin clients through VXC. And then you have Cisco Virtual Desktop Infrastructure, which is VDI, which delivers virtualized desktops, of course. There's not much more to it than that. So now, talking about the UCS C-Series servers a little bit more, and this is going to be a little bit of a review from what I already talked about, but I just got excited about it. I wanted to talk about UCS. So B-Series, of course, chassis-based. It can support full or half-width blades, meaning that you can have one that's a little bit less expensive, one that's a little bit more expensive with more power. And then one requires the storage area network for the application data storage. This is an important point. You can get blades with local storage on them, meaning a local hard drive attached to the blade. But in a data center environment, you're probably going to have a storage area network configured anyway. And so the best thing that you can do is have these B-Series chassis connected to the storage area network so that you can utilize the capabilities of that storage area network for storing your VMDK files, the virtual machine disk files, or snapshots, or anything else that you're going to store from your VMs. That way, if you do ever change servers, then it's all the data is all stored on the same SAN. You're just connecting different pieces of equipment to make sure that you get that same connection. And that's kind of alluding to the requirements that we were talking about earlier. Is that they have to be on the same SAN. Well, of course, if they're on different SANs, then those files aren't there unless you have some type of replication set up between those two SANs. But you have to be able to have those files in the same location or accessible at least in order for those virtual machines to be moved or any advanced features like vMotion to be used. C-Series servers, like I mentioned before, are just the rack servers. They have everything contained within them: CPU, memory, and storage. And then you can have them configured in a RAID configuration. They don't have to be configured in a RAID configuration. It's probably a good idea though, since you're going to be using a bunch of different virtual disks to be stored on that one disk. So you're probably going to need a lot of storage space for this to happen. And there's a couple. You can provision these a couple different ways. Now that I'm talking about storage, is that you can say, I'm going to use this UCS server to, to provision the storage automatically right off the bat. So if I'm going to have an 80 gig hard drive for CUCM requirements, then it's going to take 80 gig of your storage right away. Now, if you say I want to do thin provisioning on this piece of storage, that means that I'm going to allocate 80 gigs to this virtual machine, but it doesn't actually use 80 gigs on the VMDK file yet. It's going to say, you know what, I'll just use what I need until I reach 80 gigs. The server itself, the virtual machine server itself, has no idea that it's actually thin provisioned at all. It thinks it has 80 gigs, and it does. It can go all the way up to 80 gigs if necessary. So UCS Manager is used to control both B and C series servers. I've only used it with B series personally, but what it can do is, you can control physical assets within the chassis, meaning like if you have CPU, memory, and storage, that you want to put within a service profile, you can configure, these different profiles to load different types of servers, or configure the server in a different way, and then you can configure your virtual machines on top of that. So a bunch of different layers is what we're talking about here is all. These fabric extenders and fabric interconnects communicate with the data center infrastructure. So fabric extenders, fabric interconnects are just a way for you to get essentially to these storage area networks and the networks that exist within the data center. So fabric extenders, I believe, are only used with C series modules, and then the fabric interconnects would be with the B series. And then the last thing here, the last bullet point, is this Open Virtualization Archive templates, OVA templates. If you've installed a virtualized UC server within the last couple years, even you probably used an OVA template before. It's basically what it is. It's a pre-configured template with the requirements that are necessary to run that server. So let's say that you have a CUCM deployment that wants to support 10,000 users per server. Well, there's a specific OVA template that corresponds exactly to that. So you load that OVA template, and then you start configuring your virtual machine, or start configuring your actual call manager system that way, or whatever other server you're configuring, UCCX, Unity Connection, IM Presence. Question here. So Nexus stuff. Fozzie's our Nexus guy. If you guys have any Nexus questions, just talk to Fozzie. He's the man with that. So Fabric Extender, you can use it with Nexus 5K as an extender for ports. You can use a extra module, is what he's saying there. So appreciate that info there. So all right, any questions on UCS servers here? All right. A couple important pieces of information here with UC on UCS deployments specifically. There are a couple different types of configurations that are used, and we can go check out this webpage to kind of show you more about it. But also there are a couple links. I didn't really touch on this earlier, but there are a couple links I've embedded in here that I feel are really important for you to check out in addition to the presentation. A lot of these links you can kind of spend hours on if you really wanted to. So I think they're good study links to check out. So the first thing, tested reference configurations, TRC. This is for customers who want to have everything in a nice, neat little package. They want everything tested out and ready-made for them to work correctly. So they want a package solution pre-engineered for a specific deployment scenario. So if you want a cluster that's going to support X number of users, you have to use the correct tested reference configuration, meaning you're going to have this specific server, this specific OVA template. It's going to be tested and approved by the business units at Cisco that be, and they're gonna say that these tested reference configuration is ready to go for this specific implementation, and it's configuration based. So it's going to be based on the type of configuration that you're going to have in your system. So that means like your UCS servers are going to be configured in a certain way, or this specific server is going to be used or whatever. So that's what that means. They're configuration based. The UCS specs based server is just, you can use generic server hardware for it, but it is validated by the UCS BU. And this particular server is going to be rules based, which means that you have to have a certain amount of CPU, memory, hard drive space. There has to be specific rules that are followed in order for this to be a supported thing. So UCS specs based is what that is. And then third-party server specs based is when you don't really require any BU testing at all. You don't require any specific hardware. You just want to get virtualization going on any platform you can, and that's completely fine. You can do that. It's third-party server specs based, and you have to just follow the rules that are associated with that. So you have to have a certain amount of, XYZ CPU, memory, hard drive space, and different speed requirements and so forth. But they have to be met. So if we click on that real quick, this is the web page I was talking about here, the UC virtualization supported hardware. So this has a couple different tested reference configurations here, or a lot of different ones actually, for different specific things that you might look at. So let's look at C240 here. So you can see exactly what we're talking about. When we have this UCS server, the part number of the UCS server, we have 8 gigabytes DDR3, 1600 megahertz, very specific RAM, one of the following RAID controllers, everything is outlined here. So if this is, if you want to build a specific server, this has been tested by the Cisco UCS BU and ready to go. So if I look at, let's see here, VMware requirements, can I use this server section? This is kind of a cool section because basically it'll tell you what's going on. And so you have the UC and UCS TRC spec-based and third-party spec-based. And you can kind of see the difference between all of those when it comes to the differences there. So you have B series and C series on TRC, of course, and the different servers that you can run with spec-based, the third-party servers, and then third-party server spec-based where you can kind of pick the server that you want, as long as it has certain rules that are applied to it, rules that are followed. So this is definitely a good link to check out in your own time. I would spend, an hour looking through it and make sure you understand it. All right, back to the presentation here. And all right, answer files. Pretty cool thing that, this has been around for a little while, but answer files are a good way to basically pre-configure all the settings that you're going to have in your call manager installation. So if you don't want to sit at the server screen all day and just pound at the keyboard, when this installation is going on, you can just apply this answer file and walk away. So it saves time, of course, because you can do other things, and it also prevents typos or omissions because you're going to be, making sure, double checking everything, in this nice little tool that's provided, which I can go to in a second, which is the answer file generator. The UC applications can be installed on UCS with the platform config XML file, where the virtual machine requires the use of a virtual floppy drive. So this platform config XML file is the answer file, and that can be loaded on UCS using this virtual floppy drive. So floppy drives are making a comeback, man. Well, not really, but they're still cool, right? We like floppy drives. So you can use the answer file generator on Cisco.com to go through and configure your answer files, select your version. Let's go there real quick and check it out. So this has, the ability to do a physical server or a virtual machine. And for some reason I can't select that, so not sure why. But anyway, the moral of the story is you can select any version here of Communications Manager. And then it's going to allow you to type in administrator username, password, application username, everything that you would normally type in the installation screen for a server. So it's very useful. Then at the end you can just generate this answer file and then upload that XML file to the UCS server, and you would mount a virtual floppy drive to, of course, connect to that server at that point. So a couple questions here. No more physical server installs of CUCM. Thank you for that. That makes a lot of sense. I didn't get Earl's question there. Okay, sorry, can't be supported on physical. Can you apply patches during the install? You can apply patches. I'm not sure if you can do that through the answer file. I don't think you can. Yeah, you can definitely do it through the install, but not in the answer file. Okay, so that's what the answer file is. Very useful to save time. Helps out a lot for sure. So the next line here allows input of items that be answered, of course, during that install setting. You can create a virtual floppy image, which is a VMD or FLP extension, as if you needed another acronym to remember. But that will be the extension of the file that will be used to generate this on the VMware side. You mount the image in the virtual machine settings, and then you access that image during system installation. So it'll ask if you have an answer file, and then you can just provide that via the floppy drive, and that's it. Not much to it other than that. So now, before I go to the section questions, there are just four pages of them, so I think there's just 8 questions on the section. I want to just read the question out loud. I'll read the options, and then maybe just think about it for a second, and then pop your answer in the chat window. And if you don't want to know the answer, people that are thinking about it, don't look at the chat window. So people might have this answer pretty quickly. So we'll go through these slides, and then we'll try to sum up this first lecture here. All right. So which deployment model uses media resources that are guaranteed to be located at the same logical site as CUCM? So that's either campus deployment model, centralized deployment model, distributed deployment model, or both BNC. Okay, so it looks like we have several A's here. We also have one B and C. A is the correct answer in this case because you're going to have in your campus deployment model, every resource is located at that one site. In a centralized deployment model and a distributed deployment model, it's possible to have media resources at different locations. So if you're going to have media resources or gateways or anything in your system with centralized or distributed models, those will not be located at the same location. I mean, the only one that can do that is campus deployment model. That should say physical site. Thank you. Sorry about that. See, this is why we send the slides out later. Yeah, this is I guess you can call it the beta, right? All right, so next question. How does Cisco proprietary PoE detect a device requesting power? Is it A, MLP, B, LFI, C, FLP, or D, only manual configuration is supported? A resounding answer of C's. Awesome. Cool. So I must have explained that one good. All right, moving on. Next set of questions here. 3 questions here. First one, DHCP option 150 contains addresses of call processing servers. True or false? Another resounding list of B's, which is correct. It is false. It does not contain addresses of call processing servers. It contains addresses of TFTP servers. However, there are 2 servers that can overlap with each other. I mean, you can have a call processing server that also is a TFTP server. But good catch. I wasn't asking that in this case. So, all right. Next question. Peer firmware sharing will be engaged by phones that reside on different subnets. True or false? Excellent. Right on the money, fellas. That one is false because it needs to be on the same subnet to actually perform this peer firmware sharing process. Next question. How does CDP send its messages? A, with layer 3 multicast. B, layer 2 broadcast. C, unicast at both layer 2 and layer 3. D, layer 2 multicast. Or E, BND. A bunch of D's. You guys are all wrong. No, I'm just kidding. You guys are straight up right. Good effort. So layer 2 multicast with that weird MAC address with all those C's in it is the the layer 2 multicast address. All right. Take the IP address, IPv6 address that you can see there. What's the shortest representation of that address? I won't read these out because it takes a while. Okay, we got some C's, we got some E's. C is right, and D is right. So the correct answer is E. And the reason why is because they're both the shortest possible representations of that address that you can get. So you have this FE8070040001. So that the first option here in C, that's shortened here to eliminate those 2 zeros in between 7 and 4, but leave those other 2 zeros. Now we're D, you have those 2 zeros now in between 7 and 4, but the ones between 4 and 1 are shortened. So technically both answers are correct on that one. So tricky like the real exam. That's what I'm trying for. There's going to be a lot of questions like that are just, that make you think a little bit and are difficult. Anytime you have those multiple choice questions with, option E or F, with A, B, or C, that's where it all gets crazy. So anyway, which multicast protocol assumes that every client is requesting the stream? A, IGMP, B, PIM-SM, C, PIM-DM, or D, CGMP? Assumes that every client is requesting the stream. Good deal. Everybody picked C on that one, looks like. That is correct. PIM dense mode. Assumes that every client is requesting it because it sends it to everyone without precedence. All right, last question here for the section. UCS C-Series servers are blade servers that are located in the chassis and connected to a SAN. True or false? Cool. We just talked about that one, so glad everybody got that one right. Awesome. Okay, so that concludes the questions there and also this section, the infrastructure section. You guys have any questions at all? I know I probably talked a little bit much there that time. But all right, so it is noon, a little after noon here in Central Standard Time. So we'll do lunch. We'll take an hour for lunch and be back at, let's say, I'll give you an extra 5 minutes, 1:15. And then the next section we're going to be covering is the telephony standards and protocols section. So, all right, guys, we'll see you in about an hour then.